All right, good afternoon. Good afternoon, everybody. If you'd find your seats, we're going to get started here in just about 30 seconds. All right, great. Well, good afternoon. My name is Macklin. I do industry relations on behalf of the College of Science and Engineering's Project Center. Really grateful for everybody who's here today to celebrate the student success in both our Masters of Computer Science and Data Science specialization and Software Engineering specializations today. If you're joining us online, good afternoon. Thank you for being here as well. It doesn't look like we have too many sponsors in here right now. So if you are a sponsor and you've not yet paid for parking, please come see me so we ensure that you do not get a ticket this afternoon. Students, everybody else, yes, please help yourself to food and drink throughout this event. We do ask that you don't get up to refill your plate or your cup during the presentations. This can be very distracting. And then if you need a restroom at any point, please go out the door that you came in. Men's room is to the right. Ladies and gender neutral restroom is to the left. The only thing that I really have to say before bringing up our Project Center Director for some opening remarks is that you do not have to stay for the entirety of the event, but please do not get up and leave during the middle of a presentation, as it is very distracting. So without further ado, I'll invite Rachel Brown up, the Project Center Director, for some opening remarks. Thanks.
Thank you, Macklin. So today we are here to celebrate the culmination of all of our students' hard work, as well as our outstanding support from our industry sponsors and our faculty. I want to extend a special thank you to Professor Janija for her leadership of the Masters of Computer Science, Data Science students. Also, I'm pleased to welcome our alumni participants, Chris DeRee, who graduated from our School of Law, and Ana Mendez, who was a graduate of our Masters of Computer Science Software Engineering program and continues to support that program as a sponsor. I'm also proud to showcase that we have projects that span 4 diverse business sectors, including big tech to public agencies, from nonprofits to innovative startups. And this diversity of projects shows our Project Center's dedication to providing our students with a experience in real world across a variety of sectors in big technology. Also, looking ahead, we are excited to announce that we are expanding the Masters of Computer Science Software Engineering, that's a mouthful, from 2 quarters to 3 quarters starting next year. And this is really going to give us an opportunity to have a deeper industry collaboration and a more comprehensive project development experience. So we're excited to announce that. And now I'd like to introduce Professor Daugherty. He oversaw the Masters of Computer Science Software Engineering projects, and he's also the project coordinator for all of our computer science undergraduate projects. Welcome, Professor Daugherty.
Thank you. Thank you. Yeah, I'm here representing the computer science department today. We're very proud of these industry sponsored capstones as part of our program, and we're proud of the students that participate in them. Today, you are going to see teams from the software engineering specialization and the data science specialization. And as you can imagine, computer science is a fast-moving field. So we're constantly changing and trying to improve things. Rachel mentioned the software engineering specialization starting in the fall is going to go to a 3-quarter program. So it's going to start with a new course. That's all about scoping, working with the sponsor, getting things understood. And then you will have 2 quarters to continue with design, implementation, and working with the faculty advisor. And then that will also mean that the software engineering specialization will deliver and present at the big projects day in June of 2026, which is kind of a nice alignment. Another big change we see, and this is probably not surprising, a lot of projects now coming in with AI components. So we're pleased to see that, more projects, more faculty working in the AI area. And in fact, because of that, we're launching a new online degree, a Master's of Science in Artificial Intelligence, which starts in the fall. So we see a lot of changes in the computer science department there. We are very excited about the continuing collaboration with industry for these capstone projects. We need more next year than we had this year. So we will be looking for those. And we hear great feedback, and I would love to hear feedback from you, sponsors and students. But we hear these projects are seen as very valuable. They're a chance for students to apply what they've learned, practice it, work with a real customer on a real project, and for a much bigger scope than they usually see in like classroom assignments. So the bigger project run into those real world issues. I would like again to thank all the sponsors, the faculty advisors, the project center, of course, and of course the students that make all this possible. So if we can have a quick round of applause, thank all those people. All right, and then I'd like to give it back to Macklin so we can start these student presentations. Thank you.
Thanks so much. Just admit this person to the event really quick. All right, so just to quickly go over our schedule today, our software engineering specialization will go from 12 p.m. to 2 p.m. There will be a 5-minute break after the second presentation. Then we'll have a break after the fourth presentation, and then we'll kick off our data science specialization then. So without further ado, I'm going to invite the team from Black Swan Events and Dynasty Holding Co. up here to kick us off today. Thanks so much, guys.
Hello, everyone. We're team with Black Swan. My name is Chun Hai. Joining me today are my teammates, Eduardo, Maslin, and Kwon. First of all, we'd like to give a big shout out to the Project Center of Seattle University. Thank you for putting everything together and providing us with this great opportunity. It's been an honor and pleasure to work with our sponsor, Chris and Taryn. Their passion for their dream is infectious and is one of the key factors that motivate us. We'd like to say thank you for letting us explore, to be creative, and have fun. Professor Spinney is our advisor. He's very knowledgeable, helps a lot with his experience and expertise. Thank you. We'd also like to thank Professor Dartrey. Thank you for coordinating everything. Our project, our presentation will cover project overview, technical solution, design approach. We'll also talk about implementation, usability test, lesson learned, and conclusion. Our project is UI UX design for Black Swan events, which is a subsidiary of its parent company, Dynasty. This platform is designed to facilitate creation and organization of sports event, to fostering community engagement through local sports, and also it enabling people from different regions to share in the excitement. Black Swan events empowers individuals to create and organize sports leagues, allowing all the participants to take on roles that best fit their interest. The name Black Swan symbolizes unexpected and unpredictable moment in a good way. It brings to mind a classic movie quote, life was like a box of chocolate. You never know what you're gonna get. In sports, the unpredictability is what makes every event thrilling. And the beauty of the competition lies in every participant's potential to grow, push past their limits, and shine, even if it's just for a moment. Actually, this philosophy aligns closely with Dynasty's motto, own your moment. Whether you're a top-tier athlete or underdog, every moment you seize in sport has immense value. In this project, we begin by gathering all the business requirements, defining the scope of work, setting high fidelity prototype as the final milestone. After identifying all the essential user roles and mapping out their interactions and relationship within the application, we created initial hand sketches and then refined the design through low fidelity, mid fidelity, and high fidelity stages. To ensure the application was both intuitive and functional, we conducted usability tests with participants from diverse backgrounds.
Hello, everybody. Today I'm going to talk about the technical solution and the design approach. So as you can see, we have the timeline of our projects. So first, we focus on understanding the person behind our application, our users, and we create like persona, user stories and scenarios to define and understand who is the person behind our application. After that, we started to create like the hand sketchers, the things as a user we would like to see on our application. So we put there like we create like some for example, player profile page. We started to create like these isolated screens. And as soon as we have enough of these screens, we're starting to create the wireframes. And this is a really important part because that part we have to connect all the screens that make sense for our business logic and deliver a good user experience. And as soon as we had these wireframes connected, we're starting to create translating the hand sketchers on paper to the lo-fi prototype on Figma. And this is another important part because that part we have to fix the links and the navigation that really didn't make sense or was not really good. And this part we fixed that link and that navigation. After that, we're starting to create the mid-fi prototype. It's basically a polished version of the lo-fi. And then we delivered the hi-fi prototype. Is our final product. So here's where we started. So to understand the user behind our application, we created like some personas and user stories. And this is one example of one. So this one is a producer persona. We have some goals and challenge. And our job is to create like a workflow that allows the user to fulfill the goals and minimize the challenge. And this is what's really important to do on the wireframe part. So as you can see, we have some design evolution. So we start off as a hands and sketchers on paper, and we translate that into the Figma prototype as a lo-fi. And then we polish a little bit more on the mid-fi prototype, and we deliver the high fidelity one as an MVP at the end of our capstone. And as you can see in the picture, the third picture is the hi-fi prototype after we finish to complete the UI UX prototype. We also had opportunity to work with the design graphic team from Seattle University. So the sponsor contact them and ask them to create the logo, the primary logo and secondary, and also to give some palette color inspirational. So they come up with this the yellow, gold, beige, and red, and we incorporate this into our project. So this is the final version of our product, and we have some different variation of color palettes based on the inspiration they gave to us. And I'm going to hand it up to Maslin to do the usability testing.
So like any good UI UX project, you want to test your design that you've come up with. And so our sponsors selected 10 users from diverse backgrounds and ages for varied perspectives. These people were retired coaches, grandparents, parents, and sports fans. Black Swan is going to be used by a wide range of ages. And so we wanted to make sure that this design is intuitive for everyone. We tested each role, primary task, and for the player, producer, and staff role. And then this was done using Figma's prototyping feature where we set up navigation between all the screens. And we did it remotely using Zoom, which allowed us to get such a wide sample range. And our key metrics were the number of misclicks, time to complete the task, overall difficulty, and the task completion rate. So these were the scenarios that we provided to our users. So the player scenario was find and apply to a sports event from the home screen. For the producer, it was just simply create an ice hockey event, selecting a venue, staff, and players. And the staff scenario is find and apply to a job from the home screen. So this allowed us to test those primary tasks that are going to be repeated quite a few times. So what we found for this user testing was that most users found the tasks easy to complete. Navigation felt pretty familiar like other booking apps. So that was pretty good that we worked that in. And so those affordances were there. So there's issues with event creation. So some of the buttons were too small. They didn't quite stand out or just hard to tap on. And so for older users, some text is like a little bit harder to read, or tapping on those buttons can be difficult, especially if you have like fake nails or longer fingernails. So we fixed that and got that cleaned up. And then we also received the suggestion to rename our old independent contractor role to simply staff, because it just rolls off the tongue a lot better, and independent contractor is pretty complicated.
All right, so now we will go through the short demo of our project. Let me start. So when you first open the app, you will be requested to sign in or sign up. For sign, we offer the users to use SSO or email. So let's go with SSO for today. After you review the terms and conditions, you can go ahead and choose the role that you will be use the app as for today. For each role, you will see the brief description of your responsibilities for the app, players, producers, staff, or sponsors. I will go with sponsors for today. I mean, producers for today. You have to review your basic information before you head to the home screen. The home screen is categorized into 3 different sections: current, draft, and finish event. You will also see on the bottom, the navigation bar. The home icon is for this home page. Search is for the most powerful search bar across the app comparing to other user search bar. You also have save event, chat, and profile page. You can access to more function by going to the menu bar for save sponsors, staff, and venues. You can also access to your rulebooks. So first, let's get started by create a sport. Although we have a lot of sport, let's go with ice hockey for today. Professional tier is based on the player's rating, determined on the other aspect of the app. So I will go with semi-pro for today. After you input some basic information about the event, you can go ahead and choose your venue, staff, and sponsors. You can send an invitation out after you review their basic information. For staff, the same thing, but then you can also compare up to 2 sponsors to view their basic information, such as their job title, rate, availability, as well as some popular offer package. After that, of course, you can send an invitation out to one or more of them. And you will do the same thing for sponsors. At the bottom, you will see the checkbox for by invitation only. If you leave it unchecked, basically your new created event will be seen and viewed by everybody who uses the app. If you check it, then only the people who you send the invitation out will be able to view the new created event. After you save it, the new created event will be shown as the first items in the draft event category. So next, let's go through how we can communicate, how producers can communicate with all the users in the app. In this page, you can view all the chat that you currently have, or you can also filter it out by event or by different user role. On the top right corner, you see the notification icon, which can let you know new message or new offer for the event that you send the invitation out. In here, you can either chat with them or edit the invitation for more details, or you can basically just keep chatting with them for offering or negotiate the app. And basically that is our short demo for the project. I will go back to the presentation. So let's go through some key takeaways that we learned during this experience. The first thing we learned is that scope management is important. No matter what we do or which decision, which way method we use, we have to ensure that it aligns with the project requirements without overextending or under-delivering the provided scope. Next thing is that collaboration in any situation is the most important key to success, not just within our team, but also between us, the professor, advisors, and the project owner. We have weekly meeting to verify what we did in the previous step meets their expectation, and as well as we can have a chance to adapt any changes or any modification based on their feedback. The next thing we learn is that we have to pay attention to basically all the details, from page layout, the whole page layout, font size, color contrast, or the position of a button, because they all have significant impact on the user's accessibilities as well as usability. And the last thing we learned, which we think is the most important, that we try to aim for from the beginning, is that we have to learn how to think as the users. As we're putting ourselves into the user shoe, not only we care about the technical term, but then we also have to care about how to give them the first impression, as well as all the impression for the page they open. For conclusion, we all agree that this UI UX design process is structured and iterative journey. First, we have to gather all the feedback and requirements from the project owner to determine which way, method, and how we should proceed with the work. We then define, combine the key persona, a lot of them, and scenarios to have a clearer vision, as well as better understanding how users would use the apps, as well as how project owner expect them to use the app. With these foundations, we then develop basic page layout, which we call the low file that Eduardo showed you before. Turn it into the mid file by adding details, decorate a little bit, putting navigation, adding interaction, interactivity into every element to turn it to the mid file before heading to the high file. However, between mid file and high file, we conducted the user testing section that Marceline showed you to verify and validate that what we designed so far meet the users, I would say, expectation, and to confirm that our design doesn't cause them any trouble using it. And of course, lastly, after all this effort, our high fidelity is a combination of carefully chose color palette, enhanced interactivity between the elements, and better usabilities to ensure that Plex One Events is not only functionally, but also visually appealing to the users. Last but not least, we handed over the project to the developer teams 2 weeks ago. So we hope that our project will be the smooth transition for Plex One Event to become reality from the concept. And that should be everything from us. Thank you for joining us today.
All right. We have a couple minutes for questions. Are there any questions out here in the audience or online? All right, let's start here with Aiden.
Any one of you can answer this. What was your favorite part of this process?
My favorite part?
Yeah.
Yeah, for my part would be making the interaction between the screen and elements. Do we have a lot of time left, Professor? Can I show them something real quick? All right. So when I say interaction, this is what I mean. So creating this spider web is my favorite part at the end of the day, every day. Yeah, so the one I showed you in demo was the demo for the producer flows, and it's also one of the most, I would say, the most important role in our project. And I always have fun with this every night, creating and clearing this whole web.
So you mentioned doing some proof of concept implementations. I was wondering what an example of that was. It's in the project paragraph.
So I can kind of speak on that. Basically, what we're kind of talking about was the in Figma, you can use like the prototyping feature to kind of walk through the entire app. So with that spider web, pretty much all the elements are hooked up to all the buttons. So like investors for Black Swan events later on down the road can actually walk through the app and continue to, figure out whether or not they want to fund it or something like that.
What's going to happen next? You said you're turning it over to developers. So I just want to make sure I understand so these screens, did you have code in your project, or you're giving it to developers that are going to implement the screens that you did?
Certainly. So I can answer that. Basically, so this project's description and the final deliverable for us, it's a bit different than the rest of the projects today, but our final deliverable was a Figma prototype with a full screen mapped out. The big thing for us that wasn't code involved with this one was because when we received the project, it was just a slide deck of an idea of what the project could be. There were no requirements. There were no business logic. So we had to spend a couple, 2.5 weeks dialing that down, figuring out how does this whole system work? How do the users interact with that? So that's where our UI UX prototype worked out as the perfect deliverable, because we could bring something with the least amount of risk possible. Whereas if we were to go into this with a full development project, I don't know how far we would have gotten, because it would have been a pretty risky situation, because there wasn't a lot of requirements. There wasn't business logic. Yeah.
All right, that's all the time we have. Let's give him another hand. Great job, guys. All right, next up, we have our Snohomish County Office of Energy and Sustainability. Please bear with us while we switch screens here.
Hello. Thank you for coming our presentation for the Snohomish County Capstone project. Yeah, first of all, special thanks to our sponsor to support us the guide they have with the regular meeting and then regular feedback. And then here is our members, and then Maisha, and then here is Yash, and then Hussein, then Yalda, and then here is Tekil. And then we also appreciated our faculty advisor, the Dr. Samabi, helping every week, to guide us a lot. Thank you. And then we structured our presentation with the 3 lessons learning as a capstone. First one is the requirement engineering, and then lesson 2 is the system design and the practical solution. Lesson 3 over the software and then just coding, how to improve our project and our software iteratively, and then in addition to that, consider about the future extension.
So we are going to begin with an overview of our project and what is it about. So the first lesson we learned as graduate student doing the capstone was requirement engineering. Understanding the requirement helped us understand the data needs for the project. So Snohomish County is the 3rd largest county in Washington state, located right above King County, and they have a large number of departments. These departments collect data to improve life of the residents and use resources wisely. They also use this data to apply for grant and to understand the need of vulnerable groups. However, their data is split between departments. For example, Health Services Department has their own database and Planning Department has their own database. This creates data silos, which waste resources and reduces efficiency. These data silos that you are seeing in the picture, they all make it hard for the department to access and share reports with each other, leading to inefficiencies and duplicated outreach efforts. So Snohomish County asked Seattle University for help to combine all of this data from all the departments into one place. The goal is to help departments work together better and reduce challenges in the community. During the last 2 quarters, we had meeting with the Snohomish County every week to work on the requirements, to create a project plan, and to design, implement, and test iteratively. This helps us to focus on a meaningful solution that meets their goal. In a scope for us is a keyword text-based search tool to pull the reports and other documents from database, a centralized metadata storage, and a simple user-friendly interface to search and access those reports or other documents. Out of scope for us would be more data science related, for example, data analysis or standardization. Now Yash will continue with proposed solution.
Okay, so our proposed solution was about doing a document repository with a searching capability for the Snohomish County users. Next slide. Yeah. So our milestones were to deliver a minimum viable product that is a prototype we made. So from the last quarter, we did integrated the front end with the back end, so they can handle the UI, and also we will be delivering the documentation made by us and the source code. So lesson 2 is all about like the requirements we gathered and how we build the prototype. So we build the prototype like deploying a MERN app, building a MERN app, and why we choose that, because MERN is secure, scalable, and user friendly for the JSON data type which we wanted for our prototype. And throughout this whole quarter, we worked like creating a pull request, and then another team member will do the code review, and then we'll do the merging of the branch. Now Hussein will be doing the demo.
Thank you, Yash. Hi, everyone. I'm going to explain the basic functionalities of our website. So firstly, we have the login page. As you can see, we are not maintaining username or passwords, but rather we are using the Microsoft SSO to go in accordance with the Snohomish County Microsoft accounts. And as you can see, we are only allowing the snowco.org domain right now. So I'm going to sign with a different email account, my personal, and it shows that I don't have that authorization. So I try the Snohomish County account, and that will lead me to my website. Now, the dashboard is interesting because it has several links and key metrics. It has a table of recent reports, a graph, and different buttons that leads us to the pages we have, such as our documents page, our new document page, our filter document page, and we also have like an about section to describe what our prototype is and what kind of features are associated with it, such as search documents, advanced filters, and document preview right off the website. To ensure that logout functionality works, I log out and I try to access a link directly, for example, the dashboard, and you'll see that I'm not able to do it unless I log in. So I'll log in back with my Snohomish County email, and I'm back to my dashboard. Now I'll invite Yash to explain the other features of our website.
Go to the next slide. Go to the next slide. Yeah. So here you can see the documents page where all the documents are fetched with the name, type, created at. So you can view, edit, add document. So I'll do a demo of add document now. So here I'll type a document name. Let's say demo. Select a department, choose a different date, set a type as a PDF. I'll give a demo link, but Snohomish County can give a real document URL. So here's a catch now. Now I can fetch the keywords and select them. What if I want to add a new keyword? So here I'll enter a new keyword and it will add a new keyword while adding the document. So you don't have to every time go to the keywords and add new keyword for adding into the document. So here I'll enter the keyword and I'll submit it. You can see that the document is created successfully. Now let's go to the filters page, which is our main attraction for filtering the documents. So here I'll take the demo name and we'll search by demo. If I click on the demo, I can go to the view document page where I can view the document. You can also visit the document by giving a real document link and you can edit and delete it as well. Also, we can filter it by department and keywords. So if I do airport now, you can see that documents related to airport are fetched. What if I want to add filtered by keywords as well? So if I do libraries, you can see every document related to airport and libraries is been fetched up. That was our main and the hardest part to do. Also, you can see the profile, which is from SSO session. Here, you can see the keywords which are fetched from the database. Here's the latest keyword which we added during adding the document. So I'll just go and do a simple quick edit into it. So if I update this keyword, the keyword will be updated successfully. Likewise, the thing worked with the department. You can just add the department, you can view them, you can edit them, you can delete them. And that's what our project works. Now, Yada will talk about the testing part.
So from the beginning, testing has been a critical part of our project, helping us catch issues early, enhance usability, and ensure security. Using Jest, we built confidence in system reliability with all test cases passing successfully. Our testing process covered system functionality, user acceptance, and security, ensuring the system met requirements aligned with users' need. As an example, following the user's feedback, we decided to allow user to add new keyword inside add new document page directly. This improvement came from the recognition that users wanted a more efficient way to add new keywords and instead of navigating to another page to add new keywords. Now, Mayasha will continue.
So we just showed you the implementation, which really wasn't our main deliverable for this project, although it's the most, I think, exciting to look at. Really what we were giving is advice and documentation of this prototype, and we were able to deliver that. Because our lesson number 3 is software isn't done until it works for the end user. And in our case, we wanted to make sure that what we built was extensively documented and clear to whoever we were handing it off to. And so we had comprehensive documentation for this knowledge transfer that would enable future team collaboration and future extension. And Tekel is going to talk about a little bit in this document how we were able to implement suggested solutions that we didn't come up with, but we think that would be beneficial for the county in the future.
Document has the 2 suggested solutions. It is to enhance and expanding the feature possibility and the system functionality. First one is the search functionality. This one is using the keyword. Keyword has the related keywords, and then the keyword is representing the subject and then department. And then when we are searching using the keyword and then retrieve the related keyword together and then patches the associated documents and then reports it tagged by the keyword. And then and then this functionality helps the locating the documentation over the department more clearly. And then next one is a Q&A Bank API. Q&A Bank API saves the repeated question and answers and the participant the responses in the database. This one helps the expected helping the reducing the repeated the demographic information over the department, and then this saved data also can be used the analysis material in the future.
In order to make this all come together, we kind of met as a team in the beginning of this quarter and sketched out how we wanted it to look like in advance. And so we were able to do that by coming up with project management tools that would allow us to define sprints that we kind of split up by feature, and were able to plan sufficiently how we were going to make this happen in the small amount of time that we had. We also decided, as an extension, future improvements. So for example, you saw on the dashboard this chart, and it was number of reports by zip code, but it doesn't really have the functionality right now to pull that. We figured in the future there would be real-time data visualization, and that would just enhance this whole system and create a more functional system for the county. And additionally, we also kind of got together and brainstormed just maybe keyword relation visualization would be better, and like just in general, better UI, dynamic knowledge. And of course, we also wrote in our documentation about how you could integrate AI to maybe help generate keywords, or in the future to analyze the data in the documents that's in the system and related queries. So passing it on to.
So I'm going to talk about our success in achieving the milestones we set in the previous quarter. So firstly, we have the minimal viable product MVP, and we were successful in building that with extensive documentation and a fully functional prototype. Secondly, we have that we needed to expand our code that we set out in the previous quarter and attach a front-end server to it so that it's more accessible to the county users, and we were also able to do it. And lastly, our goal was to target the need to have a more better system at data management, and we were able to do that as well. To conclude this presentation, I'm going to revisit the problem statement that we had, which was to create a data bank that is convenient for the county users and which reduce manual hours of searching documents. So to target that, we created a secure and collaborative platform with extensive documentation and with a lot of room for future extension. That would be all from our side. This was Team Snohomish County. Thank you so much.
Thank you, guys. Any questions for the team here? We have a few minutes. Going once. All right. Aiden again. Thank you, Aiden.
So at the beginning, you listed sort of all of the roles that everybody took on. How closely would you say that you stuck to those roles during the entire course of the project?
I think we stuck to them pretty closely, honestly. It's really chaotic when you have multiple people kind of deciding the trajectory of a project. I mean, you can do it, but it's very, very difficult. You need somebody to communicate, and you need somebody to delegate what's happening. Otherwise, you just don't do anything. So somebody had to do it. And here we are.
Definitely. Thank you.
What did you find interesting of working with your sponsor compared to other type of tech companies?
You gotta grab the other mic out here.
Here.
Okay, so the interesting part was gathering the requirements, because on the first we didn't know like what to build, how to build, and then like meeting to the sponsors, meeting to Professor Samavi, then we decided to build a prototype. So yeah, so they need a better data management website so they can manage their documents, their surveys, and all of the things at once, and they can like search it by various filters such as departments and keywords. So that was the interesting part to implement as well, the searching part.
Any other questions? All right. Oh, yep.
It's not a question, it's a comment from Shannon Bird from Snohomish County. He says, fantastic project. Thank you for the team for all the hard work.
Nicely done, team. We're now going to take a quick 7-minute break because we're ahead of schedule, and we will resume at 12:50. Thank you so much. And if I could get the Google team to come up here in a couple minutes to get set up, that would be great. No rush.
the security testing in TPM implementation. One success of our project means we can develop a fully automated fuzzing framework with the GitHub CI/CD pipeline. Another success means developers can use the auto-generated tester report to find any potential issues or any vulnerabilities in the TPM system. So what is TPM? Does everyone remember? We did that last quarter. No? Okay. TPM is basically a hardware we can find in many devices, like our laptop. It can help us to securely store some sensitive information to make sure the system can work highly secured. What about our project is the fuzzing test of the TPM system. So we are basically put random inputs to test how does the TPM system work. Some major deliverables of our project is the CI/CD automation, containerized testing environments, also the communication between fuzzer and TPM, also our fuzzing strategy, the test reporting part, and our code base with the documentation. Last quarter in fall 2024, we did the scope doc, design doc, prototype presentation, and some prototype development. This quarter, we start to implement the real thing. So we start from the GitHub pipeline setup and the Docker setup. We also did the fuzzer, both valid and invalid inputs for some TPM comments. We're gonna go through all these details in later of the presentation.
All right. Those are our technology stack. We use the GitHub for our workflow. We use Docker for containerization, and we use Golang as our programming language. Now let's dive into our CI pipeline, which is built in GitHub Action and YAML. This pipeline can be triggered either by schedule a specific time. For example, we schedule every Friday at 8 p.m. And it can be also triggered on push to the main branch or on pull request, or it can be triggered manually through the GitHub action. The pipeline itself, it's structured into 3 jobs. The first job is the command setup, which install all the dependencies and verify all the required files are present. Install the Docker Compose, and it's build and save the Docker images. And finally, it extract the test group dynamically using the configuration file. The second job is the fuzz testing, and this job is run in parallel for each for different test grouping. And it start by downloading the required images and downloading the required container images and launching the necessary containers. After testing, it generate the reports and upload the report files. And then finally, it removes the containers. The last job is the aggregate report. Once all the test groups complete execution, it download all the individual file reports and then aggregate them into final report and upload it as artifact. More details about the container itself. Each container starts the TPM simulator and then start the client, which run the fuzz testing. After that, the testing, it saves the test result to a report file and then finish and clean up the containers. This process can be tested locally using the run TPM fuzzing sh for Linux or run TPM fuzzing PS1 for Windows.
So what exactly will we be fuzzing? The TPM uses commands to perform its security operations. This can include creating keys and also encrypting data. And so we picked 6 important commands to fuzz test. That's create primary, create, sign, unseal, hash, and get random. We also, for each of the commands, picked out parameters we would like to fuzz. And then in order to maximize the efficiency of our pipeline, we wanted to run these tests in parallel. And in order to group these tests, we made a configuration file. Here you can see the test groups, the individual tests for those groups, and then also fuzzing times. So this is how long we would run the fuzzer generate inputs for each of the tests. We also distinguished it by a scheduled runtime and also development one. The development one is the shorter one with where you can run the local scripts and then also on pull requests, while the scheduled one is the weekly one, and that one is 30 minutes long. So let's get into the nitty gritty here. Our actual approach to fuzzing began with separating our TPM commands into valid and invalid tests. And then we wanted to make sure that for our tests, we had proper setup and teardown. This is because the TPM is a stateful system, so we didn't want interference between the tests. And then for our actual fuzzer, we use the fuzzer that is built into the Go language to generate the inputs and also mutate them. And we fed our fuzzers some seed inputs to help guide the coverage. And after fuzzing, we get a detailed report here. You can see that we have some clear headers, so it's easy for developers to read. It begins with initialization here, so that's setting up the TPM simulator, and then any setup like generating a key for the create command. And then here's where we actually start beginning to fuzz. And you can see that there's an elapsed time showing how long the fuzzer is running for, and then the executables are how many inputs. You can see it's going up to 81,000. And then the most important part is the new interesting. So new interesting is the number of test cases that actually expand code coverage. That's finding those edge cases, those more interesting values. And at the end, we have our cleanup here, and then whether or not the tests have passed. And if they haven't, it will give you the inputs that failed and also any errors that the TPM simulator threw.
So that was a lot of technical detail, and hopefully the following demo will make it a little bit clear for all of you. So this is the repository that we worked on. It's in the TCG GitHub workspace, and our most important branches are the main one and one that we prepare for in the future, fuzzing the CTPM implementation. Here I'm just showing some READMEs that we provide as documentation in the same repository for developers or anyone interested in understanding how our fuzzing works. I'm going a little bit into the code. One important file is the commands.go, where we code a kind of wrapper to be able to call the TPM commands itself on the simulator. I will show the example of the hash command that takes as parameters first the simulator and then the parameters that it will start fuzzing. Later we will start fuzzing. Here we have data, we have the hash algorithm and the hierarchy. And our wrapper of the command will use these parameters to execute the command, and then it will return any response and error if found. Going into the test, we have a test setup, and then we have a wrapper function for the fuzzing itself that helps with the reporting. So going to the example of the valid tests for the hash command, we can see that the first thing that it does is that it instantiates the simulator, then we pass the initial seeds, and then we will start fuzzing with those parameters and generating those random inputs that we've been talking about. Here we call our wrapper of the command hash. And I will also show the invalid test cases for the same command. The only difference is that we pass initial seeds that are not valid, such as like data that is very big or hash algorithms that are not allowed or supported. Now going back into the pipeline, this is our configuration file, but in GitHub, we can see all the previous runs. Here we can see in the main branch, both one that was triggered by a push and also one that was triggered by a schedule run. It has three main phases. One is the command setup, then the fuzzing itself that will do everything by test group, and finally the aggregation of reports. As my teammates already explained, the command setup will build the Docker images for the later fuzzing to don't have to deal with this, and because this takes a lot of time, and it will upload it back to the GitHub as an artifact. Here we can see the test group for key management secure storage. The first thing that it will do is it will start the container with the pre-built image, and it will start running the fuzzing. We can see that it logs even in the pipeline log, in the GitHub logs, it logs the reports. And we can see the other test group that we have here, which is the cryptographic operations. It does the same, very similarly, but to its corresponding command sites fuzzing. And finally, both jobs will upload back the individual reports into GitHub. The last job will take all these individual reports, merge them back together, and upload them back to GitHub for developers to check if needed. Here we can see GitHub shows all the artifacts, including the TPM emojis that I mentioned, the individual reports, and the final aggregated report. It also shows the workflow file that triggered the pipeline, and we can see it's the same one. It has the same triggers that I showed in our code. And one interesting last thing is that it takes the configuration file here for the fast tester configuration YAML, where it will take the information of the test groups to know how to trigger those jobs. And it will have for each test group and for each command within the test group, both the fuzzing time for the development and for schedule. And based on that, it will run the fuzzing for the corresponding time. That was our demo.
Okay, to optimize fuzzing efficiency, we have measured new interesting cases, execution counts, and elapsed time for each fuzz command. And so I'm just going to bring your attention over to the plots right here. Pay attention that some of the commands have a linear line, and those one are essentially saying that it stabilizes very early because it wasn't able to find any new interesting cases, while some other commands exhibits an upward trend before eventually leveling off. What does this mean? Well, fuzzing efficiency peaks early, and beyond a certain point, it's unable to find any new interesting results or paths. And so this insight allowed us to set the final fuzzing time to 30 minutes, ensuring that we maximize test coverage while without any unnecessary delays. So when it comes to a complex system like the TPM, it comes with its own technical hurdles, and we faced quite a few during our project. So fuzzing CTPM requires TCP communication. Since TCP sends raw bytes between containers, code coverage tools simply didn't work. And at the same time, we found out later on in our project that we were unable to fuzz the CTPM code. This is because GoFuzz requires direct code access. And because CTPM runs separately, it was unreachable for fuzzing. And so to overcome this, our team replaced the CTPM with the GoTPM simulator, a very complex process due to the difference in constants and implementation details. So debugging took a lot of time, but our team pulled through and we successfully adapted, and we continue to fuzzing, but with the GoTPM simulator. And so I know what you all are probably wondering. What is the impact that we bring with this project? Great question. Well, our project not only enhances security, but it also encourages people to have more confidence in TPM and sets a new standard for TPM development. So TPM is used worldwide, and our work ensures that it stays secure. And it empowers developers to detect these vulnerabilities early on. So we can take the traditional approach of using unit testing, but as some of you may know, it involves a lot of manual effort, and oftentimes it misses edge cases. And so with our approach, we ensure that it has continuous security, which in turn builds the trust in TPM security. And so our work doesn't just end there. We've outlined our next steps in our future proposal plan for the next team that's going to be picking up our project. First, we are proposing that they target the CTPM implementation, so basically enhancing the fuzzing capabilities and ultimately even integrating it with the physical TPM in the future. And next, they could implement the Markov chain-based sequence fuzzing. So we did some research on that, and we believe that this is an advanced technique that would be very beneficial to the project itself, because it would allow us to to fuzz different sequences, And we are also proposing a mutator strategy that is commonly used in networks in order to manipulate bytes to be sent over TCP. So our project used the agile approach. Every week we ran sprints that included sprint planning, retrospective, sponsor reviews, and task creation. And this structured process allowed us to stay focused on delivering high quality solutions. So to wrap up, our team has successfully built an automated fuzz testing framework to fuzz TPM commands. And we did this by developing a GitHub CI pipeline for automated fuzz testing, leverage Docker containers, and we were able to successfully fuzz 6 TPM commands while ensuring that test reports and loggings are being produced. And to wrap it all up, finalizing our project, we are going to be handing off all the deliverables listed here alongside our future development proposal document to Google and TCG. Thank you so much for your attention.
Whew, that was a lot. Any questions from the audience here? All right, well, hands are shooting up. We'll start in the back and work forward.
You showed us a demo last quarter. How did the project, if at all, change from last quarter to this quarter in terms of how you did your implementation?
Microphone's right back there.
So the short answer is that the demo last quarter was all hard-coded. So it was a way to show how we envision the last product that we would be delivering, but it wasn't actually fuzzing the TPM commands itself. As we showed in the demo, now we provide wrapper functions to pass the parameters that we need to fuzz, and we use them during the fuzzing. In the previous demo, it was just the pipeline working, but without the fuzzing. Now we have all the pipeline working with the actual fuzzing itself and real results.
Coming to you.
I have 2 questions. So you are fuzzing and you're getting code coverage. Did you find anything interesting, or what was the most interesting thing you found?
When you say interesting, do you mean like a bug?
Well, you were looking for vulnerabilities, right?
So
right.
the thing
but
is,
what? So did you find a vulnerability?
We didn't find a vulnerability.
Okay.
This TPM is something that has been like thoroughly tested and it's been used worldwide. As we said, every device has it. We did try to reproduce a bug, but it wasn't related to the commands that we defined in our scope for the fuzzing. So that became harder. But I think for the next step, it would be nice to try to reproduce one of the bugs and see if that can be detected as with our fuzzing pipeline.
So you're fuzzing 6 commands. How many are there? A lot?
A lot.
Okay.
Yeah.
Apparently 100 something.
Yeah.
There's an answer coming through soon. All right. Interactive stuff. It's great.
And
All
also an interesting thing is besides fuzzing the individual parameters, which are already 100 and which are all of them have a lot of parameters themselves. What we were saying and the research we did is it would be really interesting to fuzz the sequence of parameters itself, because as we said, the TPM is a stateful system. So even if you run the commands in a perfect way individually, but you do it in a sequence that is not correct, that could possibly potentially trigger some.
And that's what the Markov sequence or chain approach would start
and
work on.
The Markov chain and the mutator strategy. Yeah.
Okay. Very good. Thank you.
Any final questions? Oh, yeah. No problem.
Hi. Yeah, so I just want to, thank you all for the hard work. I don't think the presentation really conveys how hard this is, because they had to learn about fuzzing and about TPM, and everything was really complicated. So I really appreciate all the hard work, and I think you did an incredible job. A lot of the things we envisioned didn't work, partially because the TPM didn't even have features that you needed for the project. So we had to do some stuff on our end as well to unblock you. So I would say, you know, it did amazing. You should feel successful. The project was incredible. Thank you.
And it looks like we have one comment here in the chat.
There's a couple of comments. One is from Sarah Mustafa, says, good job, keep up the hard work. And the other is from Chris Finner. It says, +1. And also, I've been working on this stuff for about 11 years and still learning new stuff.
All right, let's give the team one more hand. All right, and our last industry-sponsored capstone project is going to be from our sound generations team. Last but certainly not least, Cecilia, is this your laptop? Of course. I'm gonna stop sharing your screen as well. If you want the clicker.
Yes.
Okay, cool.
Yeah.
So folks, after this, we'll take a break until 2 p.m. and then we will resume with our data science specialization right at 2 p.m. So please stick around, grab some food, use the restroom, and then, yeah.
Hello.
Just
Hi, everyone. Are you ready for the Sound Generations capstone team? Okay, thank you for being here for our presentations. Starting with today's agenda, first, we'll do a team and sponsor introduction. Second, solution and scope. Next, technology and architecture. After that, project accomplishments and demo. And finally, project handoff, summary, and lessons learned. Now let's get started with the team introduction. My name is Joe, and here's Joyty, Anthony, Ben, and Aiden. And we'd also like to acknowledge our faculty advisor, Professor McKee, for his help and guidance along the way. We'd also like to express our gratitude to our sponsor, Sound Generations, for their collaboration and support. A special thanks to the following individuals: Aaron, Brittany, Maya, Scott, and Sylvia for their invaluable feedback and insights throughout the project. With that, let's take a moment to explore the background of Sound Generations. Sound Generations is a nonprofit serving aging adults and their loved ones across King County since 1967. Guided by their mission to provide accessible and inclusive services, they deliver in-demand programs like Meals on Wheels and High Shadow, reaching individuals to 26,500 individuals with the help of over 1,000 volunteers annually. However, as their services expand and impact grow, their current site faced challenges with accessibilities, navigation, and inefficiency in the volunteer and program sign-up process. Now I'll hand it over to my teammate Joyty to talk about the solution and the scope of our project.
So to address these challenges, sound generation needs a strategic user-centered approach of redesign to the website, which will be more focused on improving the navigation with the intuitive layouts and also compliance with the accessibility standards. We have developed a more engaging and user-friendly content combined with visuals and testimonials that enhances the communication and trust, and also support better data collection and analysis. We have redesigned the core pages of the sound generation website using elements like WordPress site editor, code editor, block editor, plugins, and some custom templates. To produce these accessible and responsive web pages, we have condensed the critical information into as fewer pages as possible. We have also improved the Google Analytics integration to collect the data at key integration points, which helps us to understand the user behavior. We have also performed UI testing using Cypress to validate the key user interactions and workflows on the website. Let's move on to understand more about the technical aspects of the project.
So I'll talk about our technical aspects. So central to our project is WordPress. WordPress is a PHP like framework for developing blogs and like websites with no code. But for our project, we mostly did using a combination of both WordPress and PHP code. So as you can see here, for the front end, we use HTML, CSS, and JavaScript standard. For the back end, for any like dynamic elements, such as the navigation bar or like the search form, we use PHP. SQLite was used as the backend database for local database used. Apache was the web server used, and then Pantheon was the hosting platform we chose so that the sponsors can view our website anytime they want. So as you can see here, so at the start is at the contributor level, which is us. So each of us has our own WordPress server. And once we contribute a change to this WordPress server, like if we want to like commit this, then we use Git to like commit the change and then like merge it back into the main branch and then send that over to our demo site. As you can see here, so it starts at GitHub. So at GitHub, before sending to the demo site, we do automated testing first. So we ran the server like locally in GitHub Actions, discuss later, and then Cypress will run. Cypress is the CSS framework. It will run on this server. The test will run, and then once the test passes, then it will deploy to the test site. So as you can see here, Cypress is a JavaScript library. It describes the test case. So it describe like homepage content. The test case will be about the homepage and the steps for each test case. So as you can see here, like describe each. And the benefit of using Cypress that while you're writing these test cases, the tests are run live on the right-hand side here. So as you save the test, the Cypress UI will run this code continuously in the background. And so you can notice any bugs or any like errors that you make while you're writing test cases. This is all UI. So it's pretty useful. Once the disadvantage of using Cypress like locally is that every time you write a new test case, you just save it and run the test case again manually. But we wanted to automate this using GitHub Actions. So it runs automatically on commit to GitHub. As you can see here, we have 23 tests pass, and if one of the tests fail, then it's isolated that test case, and we can fix that test case in time before it's deployed to the test site. So once all the test cases pass, then it's deployed to the test site here. It's like 70 files. And then at the end, now that it's the winter quarter, we're trying to integrate our changes back into the main Sound Generations website. So what we did was we just export our theme, like our website as a theme, and send that zip file to Sound Generations for them to integrate. And once they import this file, it will just be the images, pages, CSS, any like custom PHP we write will just be merged into the main Sound Generations website. And they can just activate this website, this theme, anytime they want. So because each of us has our own WordPress server, the challenge was maintaining consistent any plugins we use, any like custom functionality we did to WordPress. Each of us has to replicate that. So for example, if I made a settings change, like added a new like functionality that is not native to WordPress, each of us has to use that same resource, like download it and then import it into WordPress. So that was a challenge. Next, I'll go to Aiden. Oh, yeah. Oh, wait.
So to effectively support the sound generations mission, we need to first understand how people interact with the website. So that is where Google Analytics and Google Tag Manager comes into picture. Google Analytics is a powerful tool which helps us to monitor and analyze the web traffic. It can answer certain few key questions like how many people are visiting the site, where are they coming from, is it from direct Google search or direct link or through some social media platforms, and what pages are the most popular among the whole website, how long do users stay on the site, and what actions do they take. Though Google Analytics gives us these valuable insights, it requires us to set up the tracking codes for different events, which can be complex. That's where Google Tag Manager comes in, where it acts as a central hub to manage all the tracking scripts without the need to edit the website each and every time. So let's see about the key tracking features that we have implemented. Beyond the basic traffic data, we have set up event tracking using Google Tag Manager to capture some user actions on the site, like tracking clicks on the donate button. As we all know, donations are a critical metric for the nonprofit, where we analyze the user interest and identify the potential drop-off. We have also implemented tracking for request write form and submission form on the most famous programs for sound generations, which are Height Shuttle and Meals on Wheels, which helps us to understand the usability issues which might be preventing the users from completing the application. We have also implemented tracking for individual program pages to measure the engagement levels and see what programs are the most attracted ones. If you can see here, the first screenshot is the graphical representation of the data that Google Analytics is pulling in it from the website. And the second screenshot is how we can debug a user action on the website using Google Tag Manager and see what data Google Tag Manager collects on every user action goes on the website. Could it be click? Could it be scroll? Or could it be just viewing for a long time? So let's go on and understand the approach that we have taken in these 2 quarters.
All right, thanks, Jyoti. So allow me to take you back to the very beginning of autumn quarter last year, where we decided to start off with a dream big idea, a pie in the sky concept for new infrastructure for sound generations to work with. We knew that they had already built up a WordPress site, but we wanted to try picking up a newer version, a newer set of tools that would give us more freedom to do development as the way we wanted to. That led us to building up this prototype using Next.js, which, if you're not familiar, it's essentially a framework that uses React, and React is a library that uses JavaScript. So ultimately, at the very base, it's JavaScript with sort of some extra stuff on top to make it more of an enterprise web application. However, we took a sprint to sort of build this up, by the way. So this was sort of very early stages, an exploratory phase, basically. It took us a sprint to build this up. And then eventually we presented this to Sound Generations, but feedback took us in a different direction, where we pivoted to focusing more on WordPress so that we'd preserve the longevity of the website once we as a capstone team were no longer working on it. WordPress is more familiar for Sound Generations, so we wanted to keep things as simple as possible for them, given they have a relative lack of tech resources outside of us working as the capstone team. So that led us to doing more of like a redesign focused thing, so keeping a lot of the existing infrastructure, building up some redesigns using Figma, industry standard design application, web-based. There's also a desktop version where we made web page redesigns and then converted them into live pages that could be tested upon and visited by users of the standard Sound Generations website. And this led us all the way to the end of the first quarter, where we entered winter break with some lessons that we'd learned. So here we're just going to talk briefly about the things that we were able to do. Lessons we walked away from the first quarter with were basically, we really wanted to step up our game when it came to software engineering practices. So we integrated automated testing with Cypress, as Anthony mentioned earlier, and then we really wanted to step up our progress tracking using Jira. So we decided to just essentially capture all of what we'd worked on up to that point and then turn them into tasks on Jira. Here you can sort of see like an example of one of the tasks that we introduced during winter break, which is not typically when you would have capstone program teams working. But anyway, so moving on, once we came back from winter break, it was time to address some feedback that Sound Generations had wonderfully gathered for us during the break. So they gave us a Word document that we turned into a list of Jira items. These are examples of those items. There are very many based on the feedback that we received. And so what we decided to do was just sort of work away at those as we were working on new features as well, which allowed us to put our money where our mouth is when it comes to stepping up our game on software engineering practices, because we were able to immediately start using Jira more effectively. And then moving on to our progress tracking. So we stepped up our game. I've said it a couple times now. You can see, especially sort of towards the beginning of January, which is when we started winter quarter, the amount of tasks, the to-dos went up way high. So we were managing all of those things. And this is sort of a cumulative progress of all the tasks that we created and finished on Jira. We completed 88% of our Jira tasks, and the remaining 12% were marked for future projects and future work. And the reason why we added those to a backlog is so that we could cover accessibility testing. So that's where we wanted to ensure that we had covered our bases when it came to accessibility improvements. So we applied Google Lighthouse, which is essentially a tool that will scan a web page and look at all the different features of the web page. And as someone who is using a screen reader might, or has low vision might, and identify all the issues. So we've got an example here on the right of some of the issues. This was on a redesigned web page that we built up, and then we made those fixes and transferred it over to bring that score all the way up to 100%. So that leads us into our documentation. Alongside our project, we wanted to ensure, as I mentioned earlier, that Sound Generations, anyone could pick this up in the future, regardless of whether they had an engineering background or not. So we created essentially a wiki using the documentation service Notion. Initially, we had planned to work with Atlassian's Confluence, which would build in very nicely with Jira, but we were having some issues when it came to connecting our progress tracker to our documentation. So we decided to use a different service and keep things simple. And we've had some feedback from Sound Generations that this documentation is really nice so far. So we're hoping that it'll impact in the future. You know, they'll pick this up and continue to develop upon it. But this should have everything that they need for anybody to pick up and start working on our project in the future. And then last but not least for this section, the moment we've all been waiting for, the demo. So we've got several videos here. I'm just going to sort of narrate over them. This is our redesigned homepage. You've probably seen it before. You'll recognize it from the first quarter demo if you were here for that. Here are some new pages. We sort of streamlined the experience and the information gathering process for all of these web pages. And these are things that any one of us could go and sort of access right now using our demo site. And the nice thing is that we decided to keep things, like I mentioned, simple and image focused. Previously, the Sound Generations web pages had a bit more text, which made things a little easier a little harder to pick out relevant information from. And then moving on to our next video. So this is a more significant redesign. There's a lot of assistance services that Sound Generations offers, and we wanted to coordinate them all into a single sort of phone book style or phone pad style menu, which would make it a lot easier for people to navigate, especially if they were not as familiar with using the web in general. So thinking about our user base. And here we sort of went with a similar idea where it's really focused on all the resources that are available to caregivers that support family members who are on the elderly side. And again, we went with a very simple layout in order to keep things as discoverable as possible. And then we had some skip links for navigating around in case people wanted to shortcut directly to the areas of interest that they were looking for. And then our last video will cover another big piece of the puzzle, which was our volunteer redesign. So here we've got this volunteer sign-up form, which was something that we were able to build up using, I believe, some plugins and tools supported by WordPress, as well as some custom code on our part using PHP. And here you can sort of fill in your information. That link, that information was not previously easily discoverable, so it took a couple of link clicks from the volunteer page to figure out where you were going. Similar with this volunteer search, we wanted to make it as easy as possible to find information without adding too much extra work for Sound Generations to do when it came to maintenance. So we used WordPress's built-in search tool to essentially allow for exposing all the different volunteer opportunities. And then next is our e-news subscription. This is built to integrate with MailChimp. So this way, volunteers who are interested in certain events or certain information from Sound Generations can receive that data or that correspondence without having to get absolutely everything. And then finally, here's the contact page. So we noticed that there are a lot of different locations that Sound Generations is technically, it's a network of different senior centers plus the main office. And we wanted to introduce more images so that people could have a sense of what those looked like. So overall, that's the demo. And then I'm going to hand it off to Ben to take us home.
So this slide illustrates our timeline and progress from the first week of January through the end of the quarter. We began by finalizing our CI/CD infrastructure and then using Cypress to test our updates. Simultaneously, we also kicked off the redesign of various program pages and set up Google Analytics. As the quarter progressed, we revamped the donation and volunteer pages and wrapped up by creating thorough documentation of all of our work over the past 2 quarters in preparation for the handoff to Sound Generations. We also included this quote just to highlight the idea that software is inherently an evolving product. It's never truly complete, even after a particular version is released to the public. There will always be opportunities for it to improve, such as with updates or new features or bug fixes. In other words, we can keep refining software indefinitely, but at some point you must decide it's ready to go live. So then in the next slide, we highlight our next steps on the project handoff. So we've outlined a transition plan that offers multiple pathways for Sound Generations to integrate into their workflow. And then over the summer, they will evaluate their options and determine which elements of our project they can realistically incorporate for either a smaller group or a new capstone team to take over. And then, so last slide, over the course of this project, we revamped key pages and on the website and implemented comprehensive Google Analytics. We also introduced new tools such as GitHub and Cypress alongside WordPress, which proved more than challenging than anticipated, primarily because we were collaborating in a group environment and not just as a single contributor as Sound Generations was using previously. One of the biggest hurdles was writing documentation. It's one thing to understand how something works, but it's another thing to explain it clearly so that others can learn it too. For example, I had a hard time writing the documentation for WordPress and for using WordPress with GitHub Studio. Or WordPress Studio with GitHub. I struggled at first to articulate the steps I'd become so familiar with. And as the saying goes, you don't really know something until you can teach it, which means we had to ensure we fully understood our tools in order to document them properly. Communication was also crucial. In a group setting, it's essential to ask for help when needed and confirm that everyone is aligned on their tasks. We made sure to keep in close contact with our client, Sound Generations, as well. As Aiden mentioned earlier, they did provide us with feedback after the first quarter. So we were able to incorporate that feedback into our designs and everything. And overall, this project was a wonderful experience, and we hope Seattle University can collaborate with Sound Generations again in the future. Thank you.
Nicely done, guys. All right, we got time for 3 or 4 questions and or comments here. Aiden, you can't ask the first question since you're up here, so no. Cecilia?
I see that you used a lot of technologies for your project, like many. I was wondering if you found any obstacle when integrating them.
Can we get on the microphone there? Thank you.
Okay, yeah. So the question was, we used a lot of technologies. Basically, a lot of them were just sort of naturally built into WordPress. But on top of the additional infrastructure that we wanted to pick up, thankfully, I think we made a lot of educated choices. So we did our research and made sure that there wouldn't be major conflicts when it came to integrating and converting between all the different mediums and tools that we were having to balance and juggle. It was sort of a communication challenge more so than a technological challenge, I would say, because all of the tools that we were using were relatively well documented. I think the biggest conflict was really just getting WordPress to play nice with anything else, which is kind of a challenge, but we got there.
Any other questions or comments? All right.
So as usual, I have 2 questions. So what kind of testing did you do on I assume on your demo site? Nothing
Yes.
is on the live site yet?
Yes.
Okay.
So our demo site, it was primarily UI testing. That's what Cypress was used for. So Cypress is essentially like Selenium, where it'll automate navigating through a website for you, and then trying to identify, okay, is the link working as expected? Can you click it, and does it take you to the right web page? So that was sort of our big focus for testing here. There wasn't a lot of additional functionality that we added that wasn't already covered by like built-in WordPress APIs. So we were mostly making API calls to WordPress that we assumed were well used enough and well tested enough that we sort of left that functional testing out of scope.
Right. And then on your demo site, so I assume the sponsor has looked at it.
Yes.
Have you had other users look at it?
Yeah, so that was unfortunately one thing that we didn't get too much time for. We were focused on setting up this project to be sort of carried along in the future. And I think that would probably be a good next step for Sound Generations to pursue with any other project teams that they pick up this project with. But for the focus of this project, we are really trying to get Sound Generations to a point where they could easily maintain their website going forward, even if their current sort of volunteer developers were no longer available. So yeah, it was out of scope for us.
Okay. So what do your sponsors think about your features? You think they're likely to adopt them all?
Yes, we went through and
Good
sort
answer.
of met with them regularly enough. And I think, we have a couple of them here today, but I don't want to put them on the spot. They were generally excited about seeing all of the changes, especially since the Sound Generations website. Previously, we didn't have too much time to show it here, but the previous website was originally designed in 2016. So the landscape of what web design looks like has changed significantly in the past 9 years. And so really this is just sort of getting them up to speed with how things look currently when you sort of navigate other websites. And overall, I think we got a lot of approval from them and excitement, especially with the new infrastructure pieces as well, because it would make things a lot more maintainable for them. So yeah.
All right, last call here. Yep.
Hello, we're the sponsors here, and I think one of the challenges definitely was we were coming from the marketing team and working with the development. And on our side, we have a lot of people who are also like part of the company who make their own website updates, which is why keeping in WordPress was one of the priorities for us as a company. And it was great to see the team wrestle with those challenges and handle both like their work and also our priorities at the same time, and also bring us up to speed with some best practices. It's going to take a little bit more time to bring like our leadership team and the rest of the departments on board with it, and that's part of the reasons why they were planning to do a handoff for future projects with CLU. But overall, we had a great experience and 2 thumbs up.
Thank you very much.
Thanks so much. All right, let's give this team a hand, everybody. All right, folks, we're going to take a little bit of an extended break here. It is 1:40. We're going to resume right at 2 p.m. with our data science specialization projects. So please grab some food, take a break, and we will kick things off with the legalese data science team at 2 p.m. Thank you. All right, folks, we're going to resume with the second half of our program this afternoon. We're now going to be hearing presentations from the Masters of Computer Science with the Data Science specialization. These are 10-week long, one academic quarter capstone projects. The order of our teams today will be Legalese, then the VisaWise team, then we have the Machine Learning Public Transit Project, and then the Domestic Violence Protection Order Project. And so without further ado, I'm going to kick it over to the Legalese team to get us started.
All right. Thank you, Macklin. Hey. So we are team 25.1, and our project is Legalese. I am Devin, and here is Nick, Lisa, and Ben. And this is an interdisciplinary project with the legal department. We have Bradley Ferber and Yana Shakalo, who are not with us today. And our advisors are Dr. Hanks over there and Dr. Juneja. So in this presentation, we'll start off with some motivation behind the project, our solution, deep dive into the technical implementation, a short demonstration, and finally, we'll conclude it with some evaluation. So, motivation. When you think about businesses, we usually think about big businesses like Apple or Microsoft, right? But the truth is, small businesses employ half of the US workforce, and they contribute almost as much to the US economy as big businesses do. However, despite that, most small business owners cannot afford legal services. And the legal challenges start early too, right? When you want to start a business, first you have to choose a business structure. And there are a lot of these, LLCs, S-Corp, nonprofit, C-Corps, and they all come with their own implications and differences. After you choose your structure, you then have to file many documents. And these are different depending on the structure that you choose. And finally, after you do all that, you still don't have a real business yet. You still have to do a lot of things. What do you do next? If you're a new business owner, you may not know who to ask even. And that's why we have Legalese.
Okay, so our solution to these problems was Legalese. It's an AI-powered business formation assistant. It's provided free to citizens of Washington State. It has a focus on data privacy. And thank you. It's focused on data privacy, and the AI is enhanced using regulations and laws from Washington State. Our AI formation bot helps users in 3 ways. First, it provides a chatbot that you can talk to, so you can solidify any questions you have about your business structure, your business ideas. If you just kind of like brainstorm a bit, you can do that with the chatbot. The next step is a summarization window where it'll take the conversation you just had with that chatbot and will summarize it in an easy to read format so you can evaluate what you just talked to it about. It creates a rough draft of either articles of incorporation or certificate of formation, depending on what kind of business structure is identified in the summary stage. And it also provides you with a set of next steps to follow if you want to try to make that business a reality.
All right, so now that Nick's kind of like talked about our main goals for our solution, let's go into the technical implementation. So starting off, we want a chatbot. So the main thing we need is a large language model. Now, because we have, as said by Nick, data privacy laws, we want a model that is small enough that it can run on our own resources instead of asking, let's say, Gemini or ChatGPT through an API. So what we did after we went through evaluation of various models, we decided to we landed on Mistral AI. And the reason we chose it is that one is open source, so we're able to run it on our own GPUs. 2, it's low energy cost, so we're able to, because we're able to run it on a singular GPU, we have cheaper costs to use. And the last one is that model change. We can change the behavior of the model depending on the system's instructions. That'll be important in a couple of slides. So let's say now, let's go through the whole solution. Before we start, we have to first take those Washington documents and have a good way of querying them to find what are appropriate for a user's question. So starting off, we take these documents and we pass them through an embeddings model. What this model does is it takes documents and assigns a coordinate to them. Think of coordinates that are closer together in space being closer meaning semantically. So what we can do is we can take a question and plot it in that space and take the 3 closest points, and those will be the 3 most relevant documents. So now let's say the user gives a query or a question. We'll take their question, pass it through the embeddings model, which will give it a point, and find the 3 or n most closest documents. So those will be the most relevant documents for that question. Then we'll add it on top of the query, which will give direct context that the LLM can use. Then after that, it's the basic, we have chat history, and we'll pass it through the Mistral instruct model, which will give out the response. And for chat history, we implemented that so that way context and details that are discussed earlier in the conversation stay relevant throughout. So the second step is, as I said before, with system instructions, we decided because this is an instruct model, we can change the behavior on the spot by changing the system commands. So we have 3 different distinct phases. We have the business structure consultation phase. This is where the chatbot tries to lead the user to figure out what is the best business type for their business idea. The second is a summarization phase, and this will then extract from that long conversation important information they need for stage 3, which is the drafting phase, where we'll go through and whatever appropriate documents are needed for them to file, we'll go through those documents and fill out the questions with the answers from the conversation. So high scale, this is all backend. What will happen is we'll have the user send the query, which will go through our public web interface, which is made in React.js. That'll go through the backend server, which will stream a token of responses back to the user, similar to ChatGPT.
Okay, so now let's go ahead and talk about our system itself, do a little demo. So this is what the front end for our website looks like. This is the Legal Beagle, which is our little assistant that you can talk with, and your query would go here. This is our summary page that's about to be brought up. And so once you're done talking, it summarizes, and then drafting and the next steps. So to start, we're going to go ahead and just introduce ourselves to our chat agent. And once we're doing that, the chat agent will say, hey, like, it's nice to meet you. This is what I do. It'll inform you on the steps, and it'll go ahead and say, give me some information. So we're saying that we're a turnover seller. We want to create a business selling turnovers to people in Seattle coming to and from the stadiums. And we have some money, we have capital, and we have good credit. So we have the ability to raise funds. And because we don't want to grow too much and we have all those things, it's recommending that we should probably go with an LLC because of those topics that we talked about. So now we can take that chat history and we can generate a summary based on it. And what you can see is that it'll encapsulate the key information. It says that, it's a person in Seattle, they're trying to make a turnover cart, and an LLC is probably the best formation for their idea. Now we're going to take that summary and we're going to use it to draft the basic documents. Right now, there's not a lot of information, so it only drafts the relevant fields that it can actually create. And since we only gave it, we didn't even give it a business name. We basically just told it what kind of summary we think, or excuse me, business structure would be best for it. It's generating these articles. And then now that we have these, you would need to take steps to start filling out those correctly. There's different key points that you would need to do in starting a business formation, like applying for a uniform business identifier. There's also other things like EINs. You have to reserve the name of your business. All of these things are steps that you need to follow through the Washington State Department, and there's rules to follow. So it provides you a little way on how to do that. Right here, it go ahead and says on step 4, apply for an employee identification number. So I don't know how to do that. We're going to go back to this chatbot now, and we're going to ask it, walk me through applying for an EIN. And the chatbot will go ahead and respond to it. It'll generate steps on how to do it, what it is, why you use it. And it tells you to apply online. It tells you how much it is. It'll tell you the website to go to. And then once this is all done, we can take this chat output and we can generate a new summary based on that chat output. And what you'll see is that now the little, at the end, little tag about adding the EI information is in there because we asked about it. So that's our system updating. Okay.
So I will talk about our system evaluation and experiments that we made. One of the main goals of our large language model is to be able to correctly classify the business type. In the scope of this project, we're just using 3 business types, which are LLCs, nonprofits, and S corporations. Another very important feature for our model is to be able to generate responses that are legally accurate and factually accurate. So for this reason, we use 2 approaches. As the base model, as it was mentioned, we're using Mistral model, and one of the approaches is prompt engineering. So basically, this is just an system instructions to our chatbot, and the snippet of our system prompt is provided on the slide. While prompt engineering can help model to help our model to generate responses in a correct way, it does not guarantee any factual accuracy. So for this reason, we're using another approach, which is retrieval augmented generation, that helps to reduce hallucinations and misinformation in large language models. So now let's go to the evaluation step. So here is the results for our classification. In order to evaluate how our model is able to classify business type provided by the user business idea, we generated 60 scenarios, and our law students manually manually assigned each of the scenarios to the correct business types to one of the three. And here are the results of classification using just base model. Using model with prompt engineering, we can observe on the slide how it was able to increase the accuracy for LCs and not LLCs in the corporation, but not nonprofits. However, prompt engineering with RAG actually helped to achieve 100% accuracy on our data set. For this reason, yeah, we're using prompt engineering plus RAG. Another thing that we need to evaluate is factual efficiency. We know that for chatbot that provides legal guidance, it's very important to generate responses that are factually accurate. So for this reason, we're using retrieval augmented generation that is known for reducing hallucinations. How we actually evaluated factual accuracy of our model. So we generated 100 questions in business domain, and then we retrieved relevant chunks from the database of business information documents specific for Washington State from our big database. And we also gave the same questions to model with RAG and without RAG, and computed cosine similarity score, which is basically just a score between 0 to 1 that shows how two texts are similar or not. And for each of the questions, we took 1 minus cosine similarity, achieving hallucination score. Basically, a lower hallucination score means that factual accuracy of the model is higher. So let's look at the metrics that we achieved. We can observe that we were able to reduce hallucinations based on the mean max values. The same tendency can be observed on the box plot on the right. And here also hallucination score distribution for model with RAG, which is orange, and without RAG, which is blue. So we can clearly see how RAG actually helped our model to reduce hallucinations and misinformation and provide more accurate factual accuracy.
Okay, so for sake of improving this model, what we'd like to do next is expanding the type of businesses that it'll actually help you classify. Right now, it's only focused on nonprofits, S corporations, and LLCs, but there's also other things like C corps and sole proprietorships and 15 others, but those are the big 5 that people usually incorporate as. We also were talking about trying to, right now it only works for Washington State. Delaware is the main state that most businesses incorporate in because they are really just friendly towards businesses tax-wise. And so that would be huge because it would enable a pretty sizable chunk of the populace to also be able to use our services. And then other things just like enhancing usability and stuff would make our product a little better. So in conclusion, Legalese is an AI-powered structuring assistant. It will help you solidify your business idea. It'll help you generate a summary of what you're talking about so you can really focus in on the parts of your business that you like, and it will help you create a roadmap on steps to take to make your business a reality. We use chat history and we use retrieval augmented generation to ensure that the answers provided by our chatbot are as efficient as possible without having any hallucinations. And we support businesses through summarization and document drafting. Thank you.
All right. Any questions for the team up here? Professor Hanks?
It's the hardest part to get right.
In my opinion, the prompt engineering was pretty tricky. Yeah, the prompt that you feed the model changes the output of the model pretty drastically, and a single word can really change the output. It's a pretty long prompt, maybe 500 words, and so there's a lot of just really switching it out and trying to evaluate to find which one works best. I think that's probably took up a lot of our time is switching that out.
Any other questions or comments?
Okay.
This is a really interesting tool. Had you also done a marketplace analysis to see what other tools are similar to this in the marketplace?
So our team didn't do that, but the legal team that we were partnered with did. It's called was it Checkerly, I believe. There is two big ones. I can't remember. Checkerly, I believe, is what it's called. And then honestly, I can't remember what the main competitor for it would be.
So then after reviewing the marketplace competitors, did you decide to turn your tool into something that was a little bit different or maybe covering an area that those other two competitors missed?
Yeah, so most of the marketplace tools right now are basically just like document drafting itself. So they don't give you any guidance on how to, which documents to fill out, what kind of business structure you want. And so I think the benefit of our product is that it gives you the guidance up front. Filling out a document, you can really do yourself, but figuring out which documents you need and why you need to fill it out is the hard part. And so I think that's the big benefit that we provide.
All right, excellent. Let's give this team one more hand. Now, welcome the VisaWise team up front, please. And whoever's standing over here, there's your mic. We'll have one person, at least one person. You're not going to be able to be seen if you're using.
Yep.
The microphone there for you all. And then are you using the clicker?
Yes.
Okay, there you are.
You want it first. Yes, that's good.
Hello, everyone. Good afternoon. So our product is called VisaWise. It's an AI-driven chatbot, which is built to help international students at Seattle University with any queries related to F1 visa regulations and work authorization like CPT or OPT. So before I dive into what our project is about, let me introduce you to my team. Sorry, give us a minute. So I'm Saloni Daima, and this is my team, Janitza Ruiz and Gauri Mitre. And our faculty advisors for the project were Dr. Prerna Juneja and Dr. Stephen Hines, and we greatly appreciate their support and guidance throughout this project. So today, our agenda is to talk about our project and say what the scope of our project is and dive into the technical aspects of our project and design approach. And then we are going to show a quick demo of how our final product looks like. And then we will discuss the evaluation and future work, and we are going to conclude it. So what our project is about. So as an international student myself, coming to abroad for further studies, it's like a huge step for us. And the journey becomes a little more complicated or scarier is when we'll have to understand all these F1 visa regulations and look for all the work authorization compliances and stuff. And like other students, we international students also deserve to be like stress-free about the compliance with these regulations and focus on our future work rather than just worrying about all these paperworks related to the regulations and stuff. And hence, to solve this problem of international students for navigating this complex maze of visa regulations, we came up with a one-shot solution, which is like a chatbot that would provide the international students with instant, accurate, and reliable uh, answers related to their any queries related to F1 regulations, CPT, and OPT. So our model is also integrated with UI, and it will be giving all the queries related to the scope, which I mentioned, which is F1 CPT, OPT, and we also made sure that the responses are adhering to the legal compliances. Let me walk you through our journey of building this project. So we started with defining our problem statement and then the scope of our project, which I just discussed. And the next step was collecting the data and storing it into the database. So the data that we collected were in like various format, like PDF files, documents, or TXT files. And then what we did was converted them into small chunks and into the vectors to store into a vector database called Pinecone. And the next step was selecting a model to train. And so for that, we evaluated 5 different large language models, and we also implemented various prompting techniques, which basically are like instructions that we provide to our model so that it could behave and like generate answers in a specific format that we want. And the model that we selected was Quen 2.57 billion instruct model. The next step was fine tuning. Like the name suggests, it's basically like tailoring a pre-trained model to a domain specific task so that it could answer any questions or queries related to the domain more accurately. And the next step was RAG, which is retrieval augmented generation. So for example, if you ask an AI a question, so it basically responds you with an answer, which is basically it was pre-trained on. But to add more accurate information, reliable, and make it more context aware, we use RAG, which basically finds all the relevant chunks or information from the database and helps the model to answer more accurately. And the last part was evaluating and testing our model. And we did that. We evaluated both our RAG and fine-tuned model and tested it with our law partners so that we make sure that the answers are legally compliant, because visa regulations are really complex and sometimes require to make sure that we are legally compliant with the answers generated by chatbot. Now, next, the technical aspect would be covered much deeper by Gauri.
Oh, sorry. So let's dive into technical solution and our design approach quickly. So first, as Saloni mentioned, we had some documents from USCIS and Seattle University website, which were in the format of PDF, TXT, and docx. Then we converted them into small chunks. Why chunking? So we perform chunking because it makes the data retrieval faster and reliable. And after that, the chunks were stored into vector database called Pinecone in a numerical format. Now, if a user comes with a query, then we have a railguard implemented, which will see if the query is valid or not. It will return an answer yes or no. And for that, we have used a small large language model, Gemini 2.0 Flash, and it will return a yes or no based on the query, based on if the query is under scope or not, like if it is related to F1 visa regulations, CPT and OPT. If it's out of scope, it will say no. So if Railguard says no, then user is given an answer in a tone that says that the answer falls out of my scope currently and I cannot answer this. However, I am ready to answer any question which falls under my scope. But if the answer is yes, then the relevant chunks are retrieved from Pinecone database, and those are attached with the query by user. And in addition to a prompt, this prompt contains instruction on how to use these retrieved chunks with the user query. These three things form a combined prompt, which is then given to a fine-tuned model, which is created by our team. And this whole thing here is what Saloni mentioned as RAG, Retrieval Augmented Generation. And then by going through this RAG, our fine-tuned model finally gives response to the user. Now, let's quickly go through the demo. Here's how our system looks. Now, if we ask a question related to our scope, such as how can I apply for CPT and what is the first step, then the first thing that our model will do is check if the query is relevant to the scope. And if it is, then it will give a short and concise answer related to the user query. But what happens if we ask something that is not under the scope of this project, which is something like, how can I apply for H-1B? Now, this does not fall under the scope, and the model answers something like, I cannot answer this question right now. And there are some functionalities like to create new chats and also access your chat history, which in which you can see that there are questions specifically related to Seattle University. And you can also delete your chats if you want. Let's jump into evaluation process. So to evaluate RAG, first we used Mixtral, which is another LLM. It's like using one LLM to evaluate another LLM. And for this, we created a data set with 200 questions and their expected answers. We compared these expected answers with our model generated answers, and Mixtral gave us a score for our generated answers from 0 to 5, 0 being poor and 5 being excellent. And we compared the results for our base model and fine-tuned model. And as we can see here, we got better results with our fine-tuned model. Before fine-tuning, the average score given by Mixtral for our generated answers was around 3.3, and after evaluation, it raised till 4.6. And the next evaluation we used to evaluate our RAG is sentence BERT. So sentence BERT calculates the semantic similarities and differences between sentences. And this gives these 4 metrics, which mean like first is context relevance, which checks if the retrieved context is relevant to the user input. Second is groundedness, which checks if the answer generated by RAG is supported by the context. Third is answer relevance, which checks for the conciseness of the answer. And the last one is faithfulness, which checks if the answer is factually correct in context with the retrieved chunks. And the scores for them were around 0.6 to 0.7 for us. The maximum scores that could be achieved for these are 1, and the minimum are 0. That's what the third column is trying to tell. Now, Janitza will take ahead from here.
Alrighty, for fine-tune model evaluation, for fine-tune our model, what we did was using 1,000 unique questions related to F1 visa, OPT, and CPT. For evaluation, we asked the LLM, we give a question along with 4 different options. We ask the LLM to choose the correct option. We do this 5 iterations over the 1,000 questions. Well, why do we do this? Because the LLMs are deterministic, and then the answers might vary. We also use 3 different prompting engineerings. We use zero-shot prompting. And we give the question, and we ask directly the LLM to give us the correct option. For 5-shot prompting, we give 5 sample questions and answers. And then for the test, we give a question, and then we ask the LLM to choose the correct option. For chain of thought, we give the question along with the 4 options, and we ask it to do reasoning. And with that information, we ask the LLM to generate the answer. We do the evaluation of the base model. And then as you can see in the graph, after doing the fine tuning, the accuracy has improved. Moving forward for project plan and
next steps for future work. The idea is to expand our scope and help international students with their visa regulations. We also are planning to integrate our tool to Seattle University website and make it accessible for students and faculty. For impact on organization, enhance student support accessibility, so the students can actually accessible and have reliable answers, and it's going to reduce the time and the visits at the office. And then for data-driven insights and university administration, what is going to help the university to gather information and improve the services for the students. For international reputation and competitive edge is just basically improving their reputation and make for the new applicants internationals, just go to the website and apply it easier. Sorry. For the lessons learned, for fine tuning, we learned that it's easier to work with pre-trained models than actually create an LLM from scratch. Effective chunking is crucial for optimizing the performance of the reg. And for our conclusion, we say that VisaWise is not only an AI tool, it's actually a solution that it helps for F1 visa regulations to make it faster, clearly, and accessible for international students. Yeah, just make it. And we also believe that student abroad is hard. Understanding your visa shouldn't be. Thank you all.
Any questions for the team here? Professor Hanks, a popular.
Your excuse me, the fine tuning evaluation, it looked like with fine tuning, you got essentially 100% accuracy. Cool. But then what role does the RAG, and presumably you're doing the fine tuning without RAG enhancement. So is the RAG stuff doing you any good at all?
The RAG is helping with like more context related to F1 CPT and OPT. So it's like helping us not to answer questions which are other than, I mean, like the model doesn't like responds with a answer which it is pre-trained on, but rather try to take the answers from the RAG that like for the context.
Oh, okay. So it's kind of a different evaluation set. It's kind of generic questions rather than.
Yeah.
Any other questions here? Yes, very good.
Okay, I have an interesting question, and this is coming from somebody who has no background in computer science. So when you were doing your testing, did you also consider language proficiency as part of how you trained your model? So for example, using incorrect syntax or other non-grammatically correct sentences for your language model to adapt to?
So for that, I think we have tested a couple of questions which were not grammatically correct, but like our model did well with answering those. And I believe because if we give like the information, like if CPT and OPT is related, it try to grasp all the information that we have in our database stored related to that. And the large language models, I believe, are really pre-trained on every kind of data, be it like grammatically correct or different languages, I must say. So I think it did well with answering such questions as well.
All right, let's give this team a hand. We'll now welcome up our ML Public Transit team. So we're actually just you're going to join the Zoom room here. We do not need the HDMI. Share your screen. Actually, I would just share the.
Okay, we are actually.
Okay, then share the entire screen. Very good. Let's just want to go over here because you'll be cut off behind the screen here. And then do you want to use the clicker? Sure, I'll take the clicker on that side. Okay, so we're the team that we made a project on using machine learning to help optimize public transit routes, and we focus especially on New York City in this case. So our team members are Maria there on the far left, Victor in the middle, and then me on the right. So we'll go over first the problem statement. Why are we doing this project? We'll go into the methodology and how we fix this problem. We'll do a quick demo of our tool as well as an evaluation and of our machine learning model. Also address a few ethical concerns and issues as well, and just finish off with the conclusion. So our problem statement is that public transit is a huge part of urban mobility. So lots of people are using it every day to go to work, but sometimes there's a lot of inefficient scheduling and also inefficient routes. So if, for example, there can be routes that don't hit a lot of points of interest or scheduling that doesn't fit to like peak hours. So that's results in a lot of overcrowding and also ends up in higher costs for the public transit as well as underutilized bus. So our goal of the project is to kind of fix that by using machine learning to help adjust the routes as well as adjust the scheduling for those routes. So we used a few different data sources to accomplish this. The first thing we did was to use the US Census data, and that's just to get the population density for, in our case, New York City, and see where there are crowded places that we might want to focus more on and where there are like less populated places. We also used OpenStreetMap as a land use and urban infrastructure data, and that's where we found a point of interest for each for New York City. So for example, there'd be a lot of schools or hospitals, and that's where there'd be a huge influx of people. So that's why we wanted to kind of adjust those routes to fit those. And then we also use transit network data, and that's where we use the New York City GTFS, and that's when we found all of the public bus transit data, such as like the current scheduling and also like the hourly ridership. And then lastly, we also use the City Bike and New York City subway origin destination data, and that's to kind of see where people are coming from and where they're leaving and kind of gauge the interest from that. And then next up, I'll go into a little bit more of our data exploration. So this is our census data, and this just has a heat map showing the darker where there's more population and the lighter where there's less. So as you can see, kind of in that top central area, there's going to be a lot of darker, and that's like Manhattan. So that's obviously going to be a huge population. And then this is exploring more into the scheduling. So as you can see, the darker is going to be where there's going to be more ridership. And then, so you can see during the peak times and when people are commuting, usually around like 7 to 9, and also when people are leaving work, around like 4 to 6, there's going to be a large influx of ridership as well. And then also we have a graph for the point of interest density. So we plotted the hospitals and the schools. So you can see like they're generally spread out. I say there's a big chunk of schools around like that middle central area, and that's going to be Manhattan as well. And then lastly, we did a exploration on the point of interest density. So this shows how many points of interest are close to a bus stop. So in the red, you can see there are a lot of point of interest around that area. So that's probably where we would want to adjust our bus stops towards.
All right. So now I'm going to go a little bit into our methodology. So first up, we used a genetic algorithm to help create our optimized routes. The way a genetic algorithm generally works is you start with an initial population. This can be a random set of paths. You usually use the shortest path between different nodes. You can also seed it with some initial correct paths to give the model kind of a better starting point. From there, it goes through a fitness assessment. This basically judges it based on how well the paths are hitting kind of points that you want them to be hitting. So in our case, this is hitting dense population centers as well as areas with high volumes of points of interest. After that, a few of the routes are selected. These are going to be the ones going forward through the next two steps, which is crossover. This is where some portions of some of the routes cross over. This can be compared to when you have in genes, when you have reproduction happening and you have crossover from different genes from the parents. After that, it goes through a mutation process. This is where you get some random mutation. In our case, this is either the addition or removing of different nodes, which equates to different stops. After that, it loops right back around, does another fitness assessment, and then continues through each of these steps again till you hit the stopping criteria. In our case, this was number of generations. So we had 20 generations and we had an initial population of 200. We also then took those generated routes, we estimated the ridership, hourly ridership on those routes, and we used a random forest regression model to predict the frequency that those routes should see. So how many trips per hour, essentially. So basically, the random forest generates different decision trees from different subsets of the data and comes to results, which are then averaged, and you get your final result. Once we got that, we evenly divide the number of trips per hour throughout the hour so that you get a consistent frequency. Now I will go into a demonstration, and I'm hoping that our live demo works well. So this is our front end. You can see these are all of our created routes. And then you have all the routes listed on the side here, along with their matching colors. If you scroll over, you can see the routes are being highlighted in the color as well as showing you the number. If you come over here and put in a route, it will load that route. Oh, my apologies. This is actually not the one I wanted to show. It'll load that route. You'll see it highlighted on the map, and then you'll also see the suggested scheduling for this. So this one you can see is a pretty popular route, high ridership. So it's suggesting some pretty frequent trips through especially those peak hours. All right, and now we will move into some evaluation. So this here is showing how well the routes are performing generally. So on this specific metric, it is how redundant are the routes. So how much overlap is there between our suggested routes and existing routes compared to how much connectivity. So in general, in a bus network, you don't want to duplicate routes, but you also do want to be able to transfer between different routes. So that is redundancy would be duplicating the whole route versus connectedness is how many stops do overlap across different routes. Overall, our model does fairly well at this. There is some duplication happening. You can see those routes up at the top end of the redundancy score. They are a little bit too redundant. They're kind of duplicating existing routes. Not ideal, but a lot of our routes are novel. Here you can see a little more how much there is of like duplicated routes on the right versus novel routes on the left. So the higher the score on this, the more duplicative that route is versus lower scores are going to be more novel routes. Here we have our clustering metric. This shows how close together stops are to each other. Ideally, you don't want like multiple stops clustered all together. You would want that to be like one stop and then have better spacing. Our model unfortunately did have a little bit of a clustering issue. It liked to produce a lot of stops close by. A lot of that's driven by the density, population density, and the points of interest density. So this would be something to improve. And then stop spacing. So this is how far apart stops are on each given route. So ideally for a local route, you want stops every block, which would be about every 200 meters. And then for an express, every other block. So about 400 meters. Our stops are a little bit closer together than ideal. So this would be another place to improve.
So now looking at specifically the random forest evaluation. So here, the mean absolute error showed us that the predictions are about 0.35 buses from the expected value. The root mean squared error had it about 0.5 off from the expected value. And so since these two numbers were close, we knew that there weren't any huge outliers with the predictions and that the errors were evenly distributed. The R squared score told us that our predictions were pretty good, like 72% of the variance in the data was captured. So the closer that is to 1, the better. Looking at this graph below here, so it just shows the hour of day and how our model predicted more routes during the peak hours of day. So they're kind of in the earlier morning and in the afternoon after work. This here shows the number of compares the number of departures per hour with the average ridership. So with the model predicting more routes during those peak hours, we see here how when the number of departures are higher, the ridership is higher, and that's because there's more riders during the peak hours. Looking at any ethical concerns and issues. So one would be that we're taking away routes in areas that are maybe underserved or less populated, but we weren't taking away any routes, so that was not an issue. Another one with adding routes, just traffic congestion is a concern, but a way to deal with this was to have bus-only lanes or priority lights for buses specifically. Additionally, environmental concerns with more buses exist, but the goal would be with sort of less congested buses that more people would be taking public transportation, therefore limiting the amount of people that are in their own personal vehicles. Then in conclusion, so some of the takeaways were that the genetic algorithm, it did a good job of optimizing the routes, creating them based on the population, points of interest, and the trip demand data. And then the random forest also created a more optimized schedule based on the ridership. Future work that could be done. So with the genetic algorithm, we could look at areas that don't have as much data. So for example, like we looked at New York City, which already has a created bus network. So almost like using it to create a bus network of its own. And then with the random forest, we could use real-time data, so real-time traffic data and real-time ridership data to create an even better real-time schedule. And yeah, thank you for listening.
Nicely done. Any questions for this team?
Thanks. One of the things I was curious about is one of the concerns is just the potential removal of routes, but your response is just no routes were erased from the map. With that in mind, it seems like there's tension between that claim and the Jacquard metrics, because it seems like according to the Jacquard measures, almost half of the routes were at least changed. So how were they changed? Did we just add more buses instead of shortening them or removing routes?
Yeah, so the general goal of our project was not to remove any routes, but instead to work with the existing bus network and add additional routes as needed. So there are some routes that maybe if you in a future project you wanted to look at and see if they could be removed or replaced with a more optimized version that our model suggested, that would certainly be a possibility. But our current project is not looking to remove any routes, simply add or slightly change existing ones.
Hi, the genetic algorithm has a really two important tasks. which is crossover and mutation. And my first question is that did you use some existing approaches, particularly these routes, because it's a little different because it's a sequence of the stops. So if you use the existing approaches, can you explain a little bit more about that? And second question is that, so you must measure about the convergence of the genetic algorithms. What's the kind of indicator or threshold you actually stop the process? Those two.
So to the first question for the genetic algorithm, we did take advantage of both crossover and mutation. Our algorithm is based on some existing research in the area. So this is not a totally novel application of a genetic algorithm. So basically, the way that it's working is it's looking at a series of nodes. These are the stops along the route. As it's going through crossover, it's comparing, okay, what if we took some of the nodes from another route and used that for part of our route? Does that improve the route? Does it make it worse? And then in mutation, we're looking at what if we added additional routes or additional nodes or took nodes away? Does that cover more points of interest? Does that cover more population dense areas? And then based on our fitness assessment, those routes are either kept or discarded. And then the second one was, I'm sorry, can you repeat the second one again?
The genetic algorithm needs to be converged, right?
Yes.
So what is the threshold where your threshold you stop the process of the genetic algorithm?
Yeah. So in my research, I came across two different methodologies. Either you let it come to a complete convergence where it thinks it's found the best possible outcome. We did not have a lot of luck with that. It actually seemed to get more and more confused the longer it went in some cases. So we gave it a hard stop. So we said, get to the best point you can, but stop at 20 generations. And that's where we got the best results.
Okay, I have a question for you, and this is comes from the contentious policy of congestion pricing that was put on Manhattan back in January. A lot of people are up in arms about it. I'm just curious, do you consider that social aspect when doing this project?
That's certainly a consideration. Public transit in general can be quite contentious, and people have a lot of feelings about that area for sure. Our main focus was on providing the information that would be needed for policy advocates, for public transit agencies to then take and show to commuters and other interested parties and say, hey, look, we did this study. This is what we're suggesting. But we did not focus a lot on the actual, how can we make this as appealing to the consumer side as possible?
Could be interested in future work. Thanks so much. Let's give them another hand. All right, folks, we have almost made it. We have one team left. So if I could get our domestic violence protection order team to come up here and get hooked up, that would be great. Thank you.
Mic check. Hello. Yeah. So, hey everyone, good afternoon. We together here are Team 4, excited to showcase our project, which focuses on streamlining the petition drafting process for obtaining a domestic violence protection order, leveraging LLM automation. So, before getting into the context and the problem statement, this is how our flow would be today. We'll talk about overview and then talk a bit about statement, then give a brief solution, and then we would talk about the technical design and the approach, followed by a short demo of what our tool exactly is, then the evaluation strategies and the ethical concerns and challenges while working. So before getting into the problem statement, let me just quickly introduce you my team. So myself, Ravi, Here is Dhyandeep, Rohit, Jesse over there, and she is Clara, who has been our law representative for this project, and of course with the guidance of Dr. Stephen Hanks and Professor Preta Juneja. So before getting into the project overview, I would like to say like it's difficult for a survivor of domestic violence or survivor to come out and seek legal justice. And the process is a bit overwhelming considering now. So we believe that one of the biggest hurdles in this process would be sounding like drafting a legally sound and complete petition. So when I say legally sound and complete, what does that mean? So basically, often the survivors struggle to put their experiences into words, that is, curate into a form of statement which might act as a crucial part of the petition. So that's where our tool comes into picture, which transforms the raw survivor statements into legally viable narratives through empathetic questioning and legal language alignment. And we believe our tool would be helpful to three of the main categories: primarily the survivors themselves, then the legal volunteers who work free of cost, and the legal advocates and the organizations. Moving forward, let's look into the deeper challenges and what our problem statement exactly is and where does the bottleneck occur. So, as we talked about, survivors face significant barriers, and those are few of them. Firstly, most of them cannot afford a legal representation, so they need to rely on the pro bono services provided. Then comes the lack of knowledge and complex form and terminology. As I mentioned, the process would be overwhelming, and due to these challenges, the survivors may submit like inefficient petitions, or they might lack details which might be necessary, which could sometimes impact their protection order or sometimes delay also. So before getting into the problems that the volunteers face, on the right side is the current flow. That is how it is happening right now. So first, a survivor submits the petition onto the Legal Atoms platform, which is the platform which handles all the violence stuff for Washington State. Then the legal volunteers from Family Law Center, they review the they manually review the petitions. And if they find any critical details missing, they chase up the survivor to get those important details, put them back in the petition, then finalize the draft. That is where the bottleneck is, because getting hold of a survivor and doing that puts them into high workload, which could reduce the number of survivors they are assisting every day. And like they should be taking up frequent follow-ups, and they should assure that they are making the petition to be legally accurate. So that is why, to squeeze that bottleneck, we would be ensuring the completeness by introducing a chatbot, which would guide the survivors through structured and empathetic questioning, which will make sure the petition is legally sound and complete, and which would minimize the delay which we are talking about by being reviewed by the Law Center students. And we believe these are the key areas of impact. We would be doing that by doing this stuff. And yeah, over to Jesse for the workflow.
Great. Thanks. All right, let's take a very high-level view of what our tool will be using. We start with the user. The user drafts a statement and sends that statement to the model. The model then revises that statement, outputs it, and more importantly, it spits out some follow-up questions. These follow-up questions will prompt our user to give some answers, which will include crucial details necessary for a complete and compelling statement. These answers are sent back to the model along with the previous statements, and the model spits out a final statement. The user then reviews this and lastly sends it to the legal volunteer. Now, we've been talking a lot about the model. Let's talk a little more about the model. So we're using Meta's Llama 3.1 8B instruct. So the 8B stands for 8 billion parameters, which refers to the size of the model. Compare this to something like ChatGPT-4, which has an estimated 1.8 trillion. It's a lot smaller, and we'll be feeding our model or giving it access to some data sources, namely the volunteer guide, because that is what we're trying to emulate, volunteer feedback. And we'll also give it the relevant Washington State legal definitions, namely those related to domestic violence. And lastly, we'll test our model on some prior statements provided by the Family Law Center. Now, our model is going to be generating a lot. Let's explain how we get our model to generate that. So we're going to use prompt engineering. Our prompt includes 3 tasks for the model. 1, identify critical missing details. 2, ask about those missing details in an informed and sensitive way. And 3, to revise the original statement to be as clear as possible. So now that we have that, let's talk about one outstanding problem. It's that the law may change. The legal definitions are only effective until July of this year. And our model only knows up to March of 2023. So how do we solve that? We're going to make use of retrieval augmented generation. So we have a database of the most updated definitions. What we're going to do is we're going to retrieve the most relevant definitions. We're going to augment our prompt by appending those definitions to the end of the statement. And finally, we'll generate a contextualized prompt, which will then allow our model to generate a contextualized answer. But that's enough with the nitty-gritty. Let's take a look at the tool itself.
Thank you, Jesse. So let's look at the architecture. Okay, so a user will come and the user puts a statement on the web UI. Now the statement, we've also integrated an audio feature, so the statement can be in text or audio. Then the web UI sends the request to a Flask server, which is our backend. And from the Flask server, it sends the text to our embedding model, which converts the text into numerical embeddings, which is used to find relevant legal definitions and guidelines from our vector database. Now, along with these guidelines, our system prompt and the user input, all of this is sent to the LLM model, which then processes it and makes a legally sound final statement, and it returns this to the user. So since it's a computer science and data science project, let's look at some of the features. So this is the UI of our screen. Now, first thing that you can notice is we have multilingual support. So the statement that we have written is in Portuguese, which is then converted into English by the model. Then along with this, we also have voice support, because sometimes it's just easier to speak to the model, and then the user can speak out his feelings. Then along with this, we also provide a chat support for any doubts regarding who can apply to a domestic violence order, or how long should you wait for it to come. Then these are some of the features of our UI. So let's look at the demo. Okay, before going into the demo, since we wanted to simulate a proper case of domestic violence, some words in this might be triggering, so just viewer discretion is advised. Okay, so let's go into the demo. In this demo, we are showcasing a woman named Sarah who wants to file for a domestic violence protection order against James, her ex-boyfriend. And as Sarah is typing the statement, we see that the statement basically says that James entered her house, unwillingly, forcefully abused her, pushed her across the wall, and all of these statements. Then James also broke her phone. So all of these details are there in the statement. It's a pretty good statement, but for a protection order, it's missing some critical details like location, date, were there any witnesses over there. So when you click on process statement, it goes to our model, and our model catches these important details, and it asks questions in a sensitive way regarding the information for it. So as I was filling the information, you can see that it feels like the location, time, there were witnesses. Yes, so Sarah then remembers, like, yes, there were witnesses, there were people who saw it. And then all of this, along with the original statement, is given to our model, which then gives a final statement. Now, the best thing about this is it's still upon the user to send the statement. So if the user wants, if Sarah wants, she can still edit the statement. Like you can see that there is the surface or object. So pushed against what? Then Sarah remembers, okay, yes, he pushed me against the wall. So the user can still edit the statement, and after the user reviews the statement, then the user can continue forward. So along with this, Sarah also thinks like, okay, now I have completed this order. Now what else do I require to send along with the statement? So Sarah will ask our chatbot that are there any other details that we need to send? So Sarah asked, what kind of evidence should I include to support the request? And our chatbot says, like, yes, you need police reports, you need photographs, you need any medical records are there. And the model also says, like, refer to someone who has experience in family law. So the model is advising all of this, and it's completely upon the user discretion to send the statement. And let's look at some evaluations then.
Thank you. So all that grind, all that hard work just to get these numbers right, and we got them right. So these are some of the, this is how we did our evaluation. We got like 17 original protection orders from the law school. We generated 50 from our own, and we passed these statements into the model, and we used deep eval library with Mistral 7B to test generate all the scores. And we tested a 1 out of scope statement, such as you can see that we put the query like, I am playing basketball, want to join? And the model just said that I cannot draft a statement that meets the legal standards for obtaining a DVPO. It tackled the out of scope question correctly. And here's the answer relevancy matrix. We achieved an average of 85.23%. So what this matrix does is it evaluates the modified statement given by the model to the original query that is given by the user. So it measures how relevant both the queries are. Then we measured the perplexity score. So the range for perplexity score is between 1 to infinity, and we want to stay as close to 1 as possible. So what this matrix evaluates is like how confident the model is in predicting the next word. So for example, I'll act as an LLM here, and a user questions me like, what is 2 plus 2? And I said 2 plus 2 is 4. So I am confident, and the perplexity score for this response will be closer to 1, which is what we want. And if I say like, I don't know, like maybe 2 plus 2 is 4. So I wasn't confident in this. So the score for this response will be much higher. The next matrix that we did was the semantic coverage. We scored like 74.4%. And what this matrix does is it evaluate the actual meaning that is captured by the model. So in our case, the actual what we mean by actual meaning is some of the important matrix such as location, date, or incident at the what location the incident happened, or these key things that we want to cover, and we are covering this by this matrix. Then the challenges and the ethical concerns. So the challenges that we are tackling is we want to maintain the survivor's own voice as much as possible. That's why the answer relevancy matrix is very important to us. And then the hallucinations, we want to reduce the hallucinations of the model as much as we can, because the model can easily hallucinate one case to another. Then privacy, we are tackling these ethical concerns. So we want to maintain the privacy of the users, and the court's acceptance for AI generated statement. This is another concern that we are tackling, because it depends on the judge whether he wants to accept an AI generated statement or not. Then for the future work, there is scope for integration with Legal Atoms, a very well-known online platform. We want to expand this to all the US, not just to Washington. There are some additional protection orders that we are looking to tap into, such as anti-harassment or stalking. Then we are planning to integrate the multilingual speech support. So like as in our demo, our model is supporting the chat, the text multilingual, but not the voice. So we want to make sure that the survivor is comfortable in their own language. And handing over to Jesse for the conclusion.
Sounds good. Thanks. All right, let's wrap this up. So let's return back to our original goal. The goal here is to try to streamline the petition process as much as possible in order to grant survivors quick legal protection using an LLM. Now, how do we do this? We use the LLM to give focused, detailed, but yet sensitive questions that would prompt the user to provide very crucial details for a complete statement. And it seems that our project so far is a success because the evaluation metrics show that our model is both capturing key details in the protection order requirements as well as preserving the user's voice. Throughout this process, we've done our best to make sure that there's always a human being in the loop reviewing statements. And I think the big takeaway here is that with human oversight, AI can empower legal professionals to help as many people as possible. Thank you.
Questions or comments for the team? Professor Hanks. Yeah, absolutely.
So this is related to one of your evaluation points and something you said at the end, Jesse, which was, and something you say there about having a complete statement. In other words, a statement that meets the legal requirements. And I wasn't sure how your evaluation metrics actually was testing whether or not at the end of the day you had a complete legally viable statement.
We did had like 50 generated statements that we generated and the 17 complete statements that we got from law school. So we used those in a deep eval package where we used Mistral 7 LLM. So it's like a combined pack. It's a package where you have to insert a model, and that is how we are evaluating our responses, and that is where the constraint is defined that location should be there, date should be there, and all those key details that we want in our statement.
Oh. Can I add on to that? So to add on to that, it's just, so the metric that Chinmay is speaking about is called semantic coverage. So in that we specified that, okay, according to all the statements that the Family Law Center have provided, they have said that, okay, so the statements have a high likelihood of succeeding when you have location, when you have time, when you have the impact details, the incident details. And all of this is something that we are ensuring that the semantic coverage metric uses to score the statements.
Hi. So in the demo you showed, after you process the statement, the LLM will generate some questions, and those questions are shown in the UI. It looks like one at a time. How was that parsed? How is the UI adaptive, or are those questions like pre-selected to be asked?
No, the UI is adaptive. So the statement is given to the model, and the model responds with a list of questions, which is then sent to the UI. And it's different. Like sometimes 4 questions, sometimes 2, sometimes no questions. Like sometimes people have a good order.
Oh, just to add one small additional note, I believe this incorporation of the customized question into the UI is one of the strengths, insofar as another tool used to file these protection order legal atoms only has a static list of questions or a static list of requirements. One, and make sure to include the date and time. To make sure to include the relevant parties, but our tool customizes it to the each user's statement.
So the question I have is regarding when the user comes into the picture for using this tool. So are they being pre-coached by a person prior to gaining access to the tool? Or is this something where you imagine the user being cold and just self-identifying in order to use the tool?
Sure, I'll take it. So they can be referred to legal atoms by the Family Law Center, but there's no requirement for that. Legal atoms itself allows users to directly file by themselves, and it gives them the option if they want to send it to a law center volunteer. And at least our tool also does not require any pre-referral from the law center.
So do you think that the tool also requires a certain amount of training before being successful?
So when it comes down to it, it's just improving your thoughts and improving your how the statement is written. There's no addition of facts that the model does. So we feel that fine tuning was not necessary, and training the model specifically on any cases was not necessary. That's why we also added RAG, because we wanted to be in terms of the Washington state definitions, and because those keep on updating. And there are some like how Chinmay mentioned, stalking or anti-harassment. So we also say that, okay, if this does not sound like a domestic violence case, so probably refer to the family law center for other cases.
We had RAG because the software is not going to be with us. It's going to be with the law center, and they are not that proficient in terms of technical. So the rules and definitions change every year. So it's like difficult to train and fine tune the model like every year with those definitions. So all you have to do is just update the RAG, update the new sets of documents into our RAG database, and that's it. You're good to go.
All right. Thanks so much, guys. Great job. Folks, thank you so much for coming out. That concludes our program for Masters of Computer Science Product today. Thank you to our students, faculty, advisors, and of course, our industry sponsors. We'll see you next year. Have a good one.